So we have the calculator class here. We have the fields exp tree, variable table, and E. We have the isOperand method, which will take a string and determine if the string contains any characters that are not a letter or digit, and if it does, it'll return false, and then if it goes through the entire string and doesn't find any character that's not a letter or a digit, it'll return true, which will then mean that the string is an operand. There's the isOperator method, which will take a string as a parameter and compare it with these operators to determine if the string is an operator or not. And then there's also this precedence method, which will take a string and it'll only be used on strings that are determined to be an operator. So it'll compare the string to these statements and determine the precedence level of it so that it can be used to determine if an operator has an equal or higher value than another operator. This is the isNumber method, which will return true if the string is an integer, and if it's not, it'll return false by these try and catch blocks. So it'll try to parse the string and convert it to an integer, and if it can't, then this catch block will return false, meaning that it's not a number. This new tree method, which will return the product of merging the two last items from the tree stack that were popped and merging it together with the top item in op stack by popping that, and then it will return the result of pushing this merged tree to the tree stack. And then this method is just the run method, so this is where the program will take a string parameter, which would be the name of the file that contains the arithmetic expression, and it will go through the file line by line, and if the current line has an equal sign, that means that this is an initialization line, so there's a variable and a value corresponding to it. So if there is an equal sign in that line, then the program will split up the line at the white spaces, and then it will take the item at index 0 of this var tokens array. It'll take the items at index 0 and at index 0 and index 2 and store them in the hash map. Var tokens 1 would contain just the equals sign right there, so only the items at 0 and 2 are stored in the hash map. And then once the line that doesn't contain an equal sign shows up, then it will proceed to this statement block. So the string to expression tree method will be called using the last line in the file, which would contain the expression, and the variable table, which is our hash map of our variables and their corresponding data. So the string to expression tree takes the string that we got from here, from our file, and it also takes the hash map that we created earlier. and it creates a new stack containing items of type expression tree. Then we have op stack, which is a stack containing items of type string, and then also string tokenizer, which will go through the infix expression line and tokenize it. So we have this while loop. So while there is more tokens in the line, it will initialize e to equal tokens.next token. So that'll be the current token that will be checked for, that will go through various conditions. So this if statement determines if the current token is a valid variable. So if it's greater than 1 and it's not a number, this means that it must be a variable that's greater than 1 letter, and that's invalid. So the program will exit, and this will be displayed to the user. So then we have the isOperand method here to determine if e, which is the current token, is an operand or not. If it is, this if block will, or sorry, this if condition so the isOperand method will determine if e is an operand or not. If it is, this if condition will determine if the character at index 0 of the token is a letter. Then we go into these try and catch blocks. So this block right here will determine if the variable has been initialized in the hash map. And if it hasn't been, then this catch block will display this message to the user, and then the program will stop. Otherwise, this means that that e is not a letter and it's just a number, so hash map doesn't have to be used for this. So it's just going to parse the token and convert it to an integer, because it was previously a string data type. This else if condition checks to see if the current token, which is e, if it equals the opening bracket, and if it does, it'll push e to the op stack. If it is an operator, then it'll check if the op stack is empty. If it is empty, it'll push e to the op stack. Otherwise, while the op stack is not empty and the precedence of the current value of e, so the current operator, is less than or equal to the top item on the op stack, and it'll pop the operators that are of equal or higher precedence to the current operator at e, and then it'll call the new tree method. And then once the while loop condition is false, it'll push the current e value to the op stack. This else if condition determines if e is equal to the closing bracket. So if it is, we have this while loop that determines if the op stack is empty, and so if the op stack is empty and the top item of op stack is not equal to the opening bracket, then the new tree method will be called, and then this popped items variable will increase by 1. So this popped items variable is used to determine if there is a urinary operator present or not. Because if you divide the value of popped items after this while loop is done iterating, the value divided by 2, the remainder of the value of popped items divided by 2, if it's equal to 0, this means that there's a urinary operator present because you need an odd number of popped items. Otherwise, if it's an even number, that means that there is a urinary operator. So this condition just checks the value of popped items, and if the remainder is 0, then it just displays syntax error to the user, and then the program stops.